Get to our panel council meeting. We'll have another short break while we set up the panel. One thing I want to talk about is exposure modeling, and here's our friend again, although he's found a friend who apparently likes exposure a little more than he does, but that's not what we're talking about. Two ways this comes up. We're talking about toxic tort exposure claims, or we're talking about environmental contamination movement through the media, the soil and water. There are established scientific methods for doing this type of modeling. There are references in your materials. There's one expert out in Boulder, Colorado with ChemRisk that has published on how to do these modeling, and she has done modeling in airborne contamination. There's information again in your materials on how to do that. So you have a basis now if the expert on the other side doesn't follow those established procedures, then you can have a Daubert challenge or whatever your state equivalent is to their work, to their modeling. Dose reconstruction, what we're talking about when we're doing exposure modeling, we're trying to, in toxic tort cases, we're trying to reconstruct the dose. How much of the bad stuff did the plaintiff get? And that's a function of two things. The first is how much of the bad stuff came in contact with the body, and that's this exposure modeling that we're talking about. There's scientific basis for doing it. And the second is how much was taken into the body. What is the bioabsorption of that toxic? So there's 2 points, and we've seen a lot of expert reports that all they do is talk about the initial exposure, how much came in contact with the body, and they don't have an expert to talk about how much would actually be taken into the body. So that's another area when you're doing these cases you need to look at, and maybe an area to attack. Modeling in terms of the environmental arena and contaminants moving through media. If you've ever done a groundwater claim and had to do groundwater modeling, it's not a cheap thing. And we can run into tens of thousands of dollars, and depending upon how far apart you're doing it. One thing we came across recently in discussions with some experts is when you have groundwater modeling, normally what you're trying to do is determine, you've got a contaminated site, you're trying to determine where the contamination came from. Traditional method is you have somebody, an engineer, go out and do the modeling. They have to do geoprobes, maybe monitoring wells, and if you got a space that's the further apart the potential source and the actual contamination is, the more expensive it's going to be. And actually last year I was speaking with an expert, and he said, well, look, depending upon what type of contamination is, all you have to do is take a sample from the contaminated area and then a sample from the potential source, and there are ways that you can analyze that to determine, not only is it the same type of contamination, but what type of isotopes are involved. And we have a case right now, we have contamination and there's 2 potential sources. One is from human waste and one is from chicken waste. And they said it's a nitrate contamination. It's very easy. You take the sample source. When you look at the isotopes, you can tell there's scientifically a difference between nitrates from human waste and nitrates from chicken waste. You look at the isotopes, very easy. Save tens of thousands of dollars. The sampling in that case is about $800 to $1,200 per sample, as opposed to the groundwater modeling probably $30,000, $40,000. And the other thing you can do is look at what other contaminants may be commingled with the contaminant of concern. And if those other commingled contaminants only exist in one source and don't exist in another, pretty good basis for saying it came from this source. So